Hello everybody. Today we're going to do some troubleshooting on a JBL JRX 100 base cabinet. The base cabinet belongs to a buddy of mine. He's had it for a while. It hasn't worked for a while. I'm not sure what happened to it. I don't know if he blew it with an amplifier, bad signal, or whatever. So we're going to take a look at it and troubleshoot it and see what went bad. To troubleshoot this, we're going to need a couple tools, and I'm going to grab those right now. First thing we're going to do is I have a tone generator, and we're going to hook this up to the input of the speaker and see if it generates a tone. Now, for those who don't know or are not familiar with tone generators, and let's see if I have my receiver here. So a tone generator, it will generate a tone. Like if you're looking for a wire or something, you could hook this up to one side of the wire, go to the other side, wherever it's at, and it's going to generate a tone. You can find it. But if you hook it up to a speaker, you should be able to get that tone through the speaker if the speaker works and if it's not blown. So we're going to give that a shot and see what happens. So I have a speak-on connector here, and I just have a hard time seeing the numbers. So I want to hook up that tone generator to this, hook this up to the speaker, and see if it'll generate a tone. I'm just taking this back plate off to get to the wires. Okay, so just a quick inspection here. So I'm looking at the ground. This one should be the ground, and then this one should be the positive. So all I'm going to do is I'm going to touch these to the ground and positive and then see if we get a tone. And I get nothing. And try this side. Nothing. Try that side. Nothing. So this is kind of telling me that the speaker has an open circuit, or in other words, blown. As we're troubleshooting here, Daniel's telling me that his buddy might have plugged in because it has a 1/4 inch input on the back, and then it has speak-on. Now, the difference between those is the speak-on connector, you plug it in, you twist it, it locks. So if somebody walks by and kicks that wire, you know, and it could possibly rip the wire, but the idea is it's not going to get unplugged from the speaker because it locks. The 1/4 inch, when you pass by and kick it, you're going to pull that 1/4 inch right out of the socket. The problem with the 1/4 inch connectors is that there's a moment in there that as it unplugs, it creates a short. Okay, so the positive and negative touch. So when that happens, what happens, right? That's our question. So Daniel thought maybe if he unplugged it with it still on, it would have blown the speaker. No, it's not going to blow the speaker. That short won't blow the speaker, but it could blow your amp output. Okay, so if it's on plugged into channel A, for example, and your amp doesn't have good protection, you create that short, and it could either pop the fuse of if it has a fuse on the output, it could pop the fuse on the output, or it could possibly burn up a transistor, an output transistor, or some component right around the output amplifier. The newer amplifiers have good protection. Usually that doesn't happen, but if you get some of the older ones, and I've owned a lot of the old school, you could not do that. If you unplugged them, it would 100% blow that amplifier. In this case, if it got unplugged, no, it won't blow the speaker. So now I'm going to pull this grill off, and then we're going to pull the speaker and then test the speaker and see if it is actually blown. The two things I'm looking for here is either the speaker is blown, that means that at some point too much power went to it, which it can't handle. The voice coil, it gets hot, and then the little wires, the little copper wires that make the voice coil, they burn, kind of like a light bulb. Basically the same thing. And so then When you put signal to it, nothing happens because there's an open circuit. But sometimes it'll also blow the speaker, but it doesn't create an open circuit. It still has connection, but that area is burnt. So and then it creates a rubbing sound in between the wire and the magnet. And it does sound like it's blown, or it sounds like distorted. It's because the wire didn't fully blow, so there's still power going through it, making the speaker go up and down, you know. But it's still bad. So you can't repair that. You got to take the cone off and replace the voice coil. In this case, I don't know yet what happened. So either there's a problem with the voice coil, or it could be as simple as one of the wires came loose. And we're going to find that out right now. This had no sound at all. And that it hasn't worked for quite some time. So now I'm just going to check these wires here to see if there's a bad connection. This one's kind of loose. It could have had a bad connection. The positive side is good, but the negative is really loose. So we're going to pull those. And because they didn't use a red and black wire, I'm just going to put a knot in the positive side. That way when I put this back, I don't have to try to figure out what is the positive side. So now the next test I'm going to do is just simply, okay, so listen to this. Get close. Okay, so that is typical of a blown voice coil. So basically, this speaker's no good. So to rebuild them, we take off all this paper here. We pull this all off. And take all this off right here. Order a whole new cone. Okay, and then put it all back on and glue it and all that. It's a little bit of a process to fix these. And you have to do it. It has to come out perfect, because when you push these speakers in and out, as you can see, it almost doesn't even want to move when you push it. But that right there is a blown voice coil. That means that so the wires are round and round like this. It's a voice coil, and they get hot to the point where they burn. They get black, they burn. I've seen them actually catch on fire. So when they burn, it creates an open circuit. That means there's no more electricity going through them, and you get that sound like nails on a chalkboard. Let's talk about the cause. What causes your speaker to blow? Okay? Being underpowered with your amplifier could cause your speaker to blow. When you're working your amp to its maximum, your amp is putting out its max voltage that goes towards the speaker. Okay? And that's one thing that could blow the speaker, because it just gets too hot. Another thing is running it on the wrong wired ohms. So like this speaker here happens to be 4 ohms. So if they had 2 of these in parallel, then you're running this on 2 ohms. And on 2 ohms, that's not a whole lot of resistance. And with an amplifier running possibly in the red, yeah, that could be a good possibility why this speaker blew. The other thing is like a distorted sound, which is caused by running an amplifier with the signal too hot. So clipping going in, you know. So the thing is that you want to run your amplifiers, it's almost like you always want to have a lot of headroom. So let's say, just for example, just to make things simple, you have your signal, everything running in your yellow on your mixer and all that stuff. When it gets to the amplifier, you also want that running below your yellow and not clipping. And that should be your maximum. You should know your limit on what you have, your equipment. All equipment has a limit. So just because I have, so many watts doesn't mean I could do a gig bigger than what I could really do. The main reason why these blow is because people push them harder than what they should. You want to have a lot of power, but you want to have a lot of headroom. So for the room size, the quantity of people, you have to have a system that's going to support that at a decent level and not have to clip it, not have to run it super, hot. So yeah, those are the things you want to look for. I have my own system, the way I run it and everything, and I think the only time I actually blew a speaker was when I was like a teenager, when I was first learning and I didn't know how to run a system. But since then, I don't think I've ever blown a speaker, because you just learn, you know your limits, you know the limitation of the equipment. Well, the waves change depending on your signal, how loud it is, distortion. Those waves, instead of being nice and smooth, they're gonna change. In simple terms, for the average person to understand, don't run your stuff clipping. Don't try to do gigs that are bigger than what you actually could do, because you're going to try to push your stuff, and the more you push it, the more chances of you damaging your equipment, whether it's your amplifiers or your speakers or your horns, your tweeters, or whatever you run. Also run the right gauge cables to your speakers. So that's another thing, is if you run a too small of a gauge to, especially even like these bass speakers, there's not a delivery of that electricity properly to feed the speaker. So that'll create heat. Heat is our enemy. So just make sure that you're running a proper gauge for whatever speakers you're running. Do you want to see this voice coil? Want me to take it apart and we can look at it? I'm going to go ahead and take this cone off of this basket, because I want to show you guys what the voice coil, for those that don't know, what the voice coil looks like and what it looks like when it's burnt, when you actually blow a speaker. So just remember that sound right there, as I push on this cone, is caused by rubbing of the wire against the magnet. I'm going to show you guys what that looks like. The only tool you need to take this apart is a knife. The cone is glued to the dust cover and to the voice coil. So this part is bad. We're going to cut it out and I'm going to show you guys. But the basket is still good. So this frame of the speaker is still good. So we could order a new cone with the voice coil and everything. We could glue it all back together and put it in, line it up and all that stuff, and then this speaker will be good again. Just to show, especially the people that has never seen it.
You could technically upgrade this then too, right? If you put a bigger voice coil?
No, it's limited by the diameter of the magnet, and you're going to see that on the inside. So it's limited by that. When you order these, you're going to order the one that goes to this particular basket. I actually own some speakers that you could order the entire basket with the cone, and you could just unbolt the magnet. So you save the magnet, you order a new basket, you put it on, and it's a done deal. Real easy to replace them. But this one is not like that. So another thing I want to mention about this particular bass cabinet, that it does not have a built-in passive crossover. So basically, this speaker is wired directly to your output of the amplifier. There's nothing in between to filter the frequency or to even protect the speaker. There's nothing in between.
So if we were to not run an external crossover, since there's not one internal, what's that going to do to this speaker?
So what it's going to do to the speaker is it's just going to be like a full range speaker. It's going to play everything that it's receiving. And it's not that that's bad. There's a lot of speakers that are full range, but you just don't get the clarity, and you don't get the fine-tuning control that you would have with the crossover to be able to send the frequencies that this speaker was actually built to produce in this box. Okay, so now I have this all cut apart, and I'm trying to pull the voice coil out from inside of the magnet, and I almost can't even pull it out. This should just come right out like nothing.
So it's like melted from it?
So, okay, now it came out. Okay, so, well, half of the voice coil stayed in. So now we got to pull it out. You could see how it ran hot, because look at the color. This should be like a gold looking color. because this is copper and it's black. Okay, this here is the voice coil, the plastic where they wrap the coil around it and then they put glue on it and it stays. The voice coil, the rest of it is still inside the magnet here. So I'm going to pull it out and look, here's where it came apart. And if you were to get a magnifying glass and look at that, you'll probably see that it's like bubbled because that's where it got hot and then it blew. And I'm just pulling this nice and easy. Look at how charred that is. Run your finger on that. Feel that.
Show the chart up here.
Let's see if there's any wire that's got left in there.
Yeah, you can see that on there.
Make sure that all the wire is out of there. I think there's some wire in there still. So this is a 3-inch voice coil, okay? Which is not too bad for a bass speaker, but like the really good speakers that can handle a lot of power are going to be like the 4.5-inch voice coils or bigger. What we're going to look at here is the amount of wire there is around this voice coil, okay? So think of this as like a resistor. See, and this is where it came together. Look at that. Okay, so it's not perfect because I don't have it wrapped around here like they did with a machine, but that's where it blew. So this here is where it got hot, which is probably close to the center. So if I was to pull all this wire out, this would probably, like if I stretched it, this would probably be close to the center of the wire. Okay, so where it usually gets hot is in the middle. If you have a short on anything, on a wire or whatever, it's going to get hot towards the middle to the point where it melted the copper and it came apart. When it came apart, now you don't have electricity going through it, but when you push this cone up and down, you hear that scratching noise. You shouldn't have that. Okay, so for those who never seen this before, this is what the back of the speaker looks like. This is the copper wire that is wounded around here to make the voice coil. To determine how many ohms the speaker is and how many watts it could handle and all that is determined by the thickness of this wire and how many times it goes around the voice coil. There are some of them that'll they'll go around several times, like, you know, all the way down and it'll go back up. They'll double, they'll double do it. So the cheaper speakers, it's going to be less wire, basically. The ones that could handle more power, it's because they could handle more, they have more resistance. This has a very little resistance. So as a matter of fact, like I said on the beginning, it's a 4 ohm. So if you were to measure the resistance on this wire, it would be 4 ohms. That's what it looks like, guys. There's your problem right there. So you could replace the whole thing for $85.